Welcome back to my YouTube channel. Today we'll be dealing with 2024 question 1. I will be focusing on last question. We'll be dealing with the last question. This is the playlist that I'll be doing. Will be last question for paper 1. I'll be dealing with this last question for paper 1. Please click the notification, or please subscribe. Click that button for subscription if you have not clicked before, and click the notification button so that you'll be notified whenever I post a new video. And feel free to share the video to your fellow classmates, and then you can comment, and then you can also like. Okay, it's fine. So we are given question 1.3. Consider the product. You have given, they say we should consider the product 1 plus 1 over 2 multiply by 1 plus 1 over 3 multiply by 1 plus 1 over 4. You must know the pattern then. These thoughts shows that this thing is contains, right? Then they say each factor in the product is form of, they've given us the form. As you can see, it's 1. That means these two remain constant. This thing, what is changing here is only n. You add 1 starting from 2. As you can see, they say n is greater than or equals to 2. N must be equals to 2 or greater than. So as you can see, it will be 2, 2, 3, 4. You see, they just add 1, 1, 1. As you can see here, is 2, we add 1, you have 3, we add 1, you have 4. But these two there, these ones, they remain constant. The one that I'll highlight there, you see, this one will remain constant. It's what will happen there. Those, they will remain constant. Only n changes. So as you can see, you must check. And then also here, it's important they say n. As you can see, n is greater than or equals to 2. We've given the interval there. So it says determine all the values of n for which the product will be an integer. Understand your English. I don't know, but understand your English. Determine determine all the values of n for which the product will be an integer. This, when we multiply what we have here, when we multiply this, the product of those at the end must give us what will be an integer. Integer is number like 1, 2, 3, 4, 5, counting number, but not the decimal number. You can also say 1,5. It's a 1,3, 1,5, what. It's not an integer, that one. We don't want numbers that has a decimals, but integers, a number that we can create 1, 2, 3, even -1 is an integer, -2 plus 5 is an integer. Hopeful that you know. You see the value that we want there will be an integer. They've told us the product will be an integer. They say will be. They've told us here, they've told us that this will be an integer. Hey, no, that will be an integer. So without wasting of time, we've given that to them. 1 point, we want that product there. As you can see, the product of that, we have this product, but it shows that it contains. So it's clear that this is a fraction. You can simplify that fraction. This is the same as when you multiply there at the top. All right, remember that 1 over 1, that's the same as 1 over 1 over 2. This is like this, will be same as like this. Then you can find your, remember we must have a LCD. Remember, these are fractions, but it shows that this thing, it contains, but we don't know. They did not give us the last product or the last two product or the last product numbers. Can see, we don't know this last one here, but we know that the format is this one. We have no idea, but all we know, we'll have this will be constant plus 1 over, we don't know what will be n here. We don't know. Actually, I don't know what is n there. Honestly, for now, I don't know nothing about that n. We are not given either way. We cannot, there's no magic. We don't know where we will find that. So they say the product, let us find the products of this stuff here. You can find the product there. So this is math, this is a fraction, right? What is this is a, you see his number, we have 1 2 3 there. We can simplify this, is simplify even this one, we can simplify it. Then you apply your math, just simplify, because the base are not the same. If the fraction, the base are not the same, you can multiply. We must supposed to have LCD, right? Then we can multiply that by 2. If you multiply that by 2, obviously we'll have, will be 2, right? You multiply that 2 plus 1 over 2, right, is what you will have there. You see, I write step by step. When you multiply by 3 there, also multiply by 3 at the bottom. On the numerator and then the denominator, you'll have 3 plus 1 over 3. Why? Because the base will be the same. I want to teach you step by step. When you multiply there, we will have 3 over 3 plus 1 over 3. If the bases are the same, we add the numerators. Sorry, I was saying the bases. I don't mean the bases. I mean when if the denominator is the same, we add the numerators. So it's what I've did on those tools. So you must know that. You must note. I'm showing you step by step so that you can see what I'm trying, what I'm doing there. So this one will multiply there, the same as 1 over 2. Also this one will be 4 plus 1 over 4, right? We have no idea. Here we have 1. We do what we do, we multiply by n. We don't know that will be n plus 1 over n. So far, this is what I know so far, right? So 2 plus 1 will be 3 over 2. Then you come here, add that, will be 4. As you can see, that will be 4. We'll have that to be 4 over 3. You multiply, you come to this, you add, there will be 5 over 4. Then here we have n plus 1 over 4. See, so let's check what is going on here. These are the products. Okay, so as you can see there, those are products. Check, 3 and 3 will cancel, 4 and 4 will cancel. You see the pattern. You see those technical, the sliding technical. You see what is happening here. You see the process, what is going on. Because this dot, they're supposed to be a veil. That veil, because we know the pattern is going like this. We know the pattern. Suppose that because you see, we know that our formula must be like that. We know the pattern, that the pattern we're supposed to use is this one. Since here we have, remember, we know the pattern, that the one, this one, here is a pattern there. We know that pattern, right? So is 1 plus something there. So as we know, this is increasing by 1. That means we'll have 1. From that, we'll have 1 over 1. Here we'll have what? As you can see, we'll have it was 2 3 4. We have this. This is a pattern that we see. This is what will happen there. This is just the pattern. Is going like that. It's a pattern that will be the pattern that you see there. So as you can see, here we'll have what? 5 like this. 2 3 4. We add 1 5. This will simply equals to what? This will simply equals to, when you multiply, there will be 5 plus 1 like that over 5. Then this will simply equals to what? 6 over 5. Imagine if you put there, let me just replace that dot here also. Let me just say there, here we have 6 over 5 For an example, we have this thing representing that it contains until where we don't know. But as you can see, I just want to see, you see we have, that means this will continue like this. We'll have this process that is going on there. As you can see, the cancellation is like this. It's like that until. So it's clearly, you can see even yourself now. It's clear that sorry about writing 4. This is n, right? It's not the 4 here. It's clear that, as you can see, this will cancel, then will continue. That means also here, this thing will continue. Is one and the same process. That means there will be a value that will cancel with the n like that. There will be cancellation like this type. Look, you see. So it's clear that there will be that slanted line. You see that. Check your process how it goes. So it's clear that will have n there, that will cancel there. We don't know, but for argument's sake, it clearly shows us that here, before the number just before the product just before the last one, it clearly shows that will be n. It's supposed to, I'm expecting that to cancel. Then we have the following one. Remember there it's supposed to have n. There we have 1. I can say this will be, I can say n minus 1 multiplied by n plus 1 over n. As you can see, now the product, this will cancel like that. As you can see there, this will cancel like that. It goes like that. Also, this will cancel with a certain thing. We don't know, but we know that this cancellation will be there. That means the intermediate, this value between, will cancel. As they cancel, we're supposed to see this. As they cancel, all these values will be 1. Like you'll have there 3 cancel with 3, will have 1 over 2. Then multiply by 1. All this 1 inside will be 1. We'll be left with 1s until there we'll have n plus 1. This is what we have there. But now remember, this is still the product. If we multiply this 1 over 2 multiplied by 1, won't change. We'll still have what here? We'll still have 1 over 2. But still, remember, it's the product. These are 1s, will be 1, 1 throughout. This thing will be 1. All these are 1s. I won't write those 1 until there. All this will be 1, 1, 1, 1 until here. As we multiply this by 1, 1, when we multiply 1 over 2 throughout with this 1, this one won't affect anything. That means we're left with n plus 1. Then we multiply these 2s. Then this will be simply equals to n plus 1 over 2. This is what we have, guys. This is the product that we have. But what is the question is saying here? We want the product to be an integer value. So this value, this must be an integer. What can we do? What if supposed to be an integer, what n can be? But as we are given, hopefully you understand this English here. We says n, understand the mathematical language, n must be greater than or equals to 2. N must be greater than or equals to 2. Remember, he says, I repeat again, all the values of n for which the product will be an integer. The product will be an integer. This is the product, actually. This is the result of the product. We have multiplied all of these things here. Right. But now we want an integer. Here we have 1. What n is supposed to be must not be, do not choose a number that is less than 2, because they say n must be greater than 2. So it's clearly, you must evaluate now. You have to check even yourself. Let's say now you have n. Let's say for argument's sake, you let n, you just try, you just check. Or you can punch your calculator, you check, you take maybe your calculator, you check. Let's say if I can make n to be equals to Remember, they say the number must be greater than what? Must be greater than 2. You must check if you choose 4 for argument's sake. Maybe you choose 4. But now, if you replace 4 there, you must see. If you replace 4 there, n will be 4 plus 1 over 2. This will be what? 5 over 2. This will give you a decimal when you punch it on your calculator. You see, there, if you take your calculator 5 over 2 there, if I punch this, you see, it will give me 2.5, which this is not an integer. This is not an integer. So you see, we have added what? This is an even number. So that means the even number, when you add 1, it won't work. It always won't work. What about if you can make n to become an odd number? Let's check if this is become an odd number. If becomes an odd number. Okay, let me take an odd number for argument's sake. Odd number. Let me make n an odd number. Let's say argument's sake, odd number, things like 5. Yeah, it's an odd number, right? Let me make n 5 there. Let's say make n 5. But we know we have n plus 1 over 2. We can come and just say n. I'll replace that n there. Replace that n there with 5 plus 1 over 2. This will be 6 over 2, which is equal to what? To 3. And then 3 is what? It's an integer. 3 is an integer. But however, this must be greater than, n must be greater than 2. So what is the least? When I'm saying the least, because if you check the integers, 3 is also an integer. 3, 5, 7, 9. So 3 is an integer. The least value that I can take, I can just take even 3, if there is 3 there. If you take 3 for argument's sake, you see odd number. Sorry about that. If you take odd numbers, you see, I want to say odd numbers. What I was meaning. Odd numbers, 3, 5, 7, 9, it's an odd number. So these are supposed to become odd number. If it's 3 plus 1 over 2, you see we'll have what? 4 over 2, which is what? Simply 2. So you see what is going on here. That means n must be an what? An odd number. So I can quickly tell an examiner. For us to have an integer, you can say n okay, must be an odd number. So just telling you examiner. So we'll see that actually what you are doing here, you know it must be an odd number. So then at least odd number, you can say n, because this they say is supposed to be greater than 2 or equal to, must be greater than. So we can just, the least number, you say greater than or equals to 3. This is your n. So n must be, the value of n must be greater than or equals to 3, because why? It's an, this is obvious, this is an odd number, but the least one among those ones. Then can be any, but you see, we said this must be odd. Examiner already understand, the examiner will understand what I'm trying to say. Must be equal. Okay, you can say if you want n must equal, okay, let me just not put that equal, n must be an odd number, right? Then you show n greater than, then that I'm talking about the odd numbers, because I've indicated that this must be an odd number. So if the examiner will understand that I'm talking about n is either n will be the values, like n will be equal, will understand that n will be values like 3, 5, 7, 9, 11, until it continues stating like that. Well, the man will understand, because I've stated this must be an odd number. Will understand I'm talking about too short. So n must be greater than or equal to 3, but under odd pattern, under odd, or do you know under odd? So yeah, so this is what it is. That is the values of n for which the values of n for the product to be an integer value. N must be greater than or equals to 3, then goes upwards as a sequence will form a sequence of odd numbers. Actually, must be a sequence of odd numbers. 3, 5, 7, 9, 11, like will form a sequence, but n must be that sequence of an odd numbers, right? So will be a number which are not divisible by 2, right? Thank you guys. Thank you guys for your time. Hopefully you understood this. Thank you guys for your time. And please guys, please do not forget to subscribe to my YouTube channel. Click that notification button and stay notified whenever I post a new video. Remember, click that notification button. I'll be posting some more interesting problems for you guys. Thank you, by the way.